If I just looked at this, honestly, for me, the thing that jumps out is that it's first order linear, because I've got a dy dx, and anywhere else that my y shows up, it's only to the first power. So that's the thing that stands out to me the most in this problem. So if I were to think about it as first order linear, then I would be setting this up as y prime plus something times y is equal to something, where that's my 3x squared and that's my 7x squared. So I'd find my integrating factor by taking e to the integral of 3x squared dx, or e to the x cubed. Then I would multiply everything through by that e to the x cubed. Observe that on the left-hand side, we have a product rule. And then undo that product rule by integrating both sides. And over here, it looks like we've got a u substitution. So if I were to do a quick u substitution and let u be equal to x cubed, my du would be 3x squared. I don't have that 3x squared, sorry, dx. I only have the x squared dx. So I could take that 7 and think about this as 1/3 du is equal to x squared dx. So that I rewrite this to be 7/3 e to the x cubed plus a constant and e to the x cubed y. And then a similar thing happened as what happened to us in the previous problem, that when I divide both sides by e to the x cubed, for that first piece, the e to the x cubed is going to go away, and we'll just be left with the 7/3. And then for the second piece, if I didn't want to write it as a fraction, I could say, well, dividing by e to the x cubed would be the same as multiplying by e to the negative x cubed. But what if you looked at this original problem and actually saw it as separable instead of first order linear? If we saw this as separable, then the idea would be to get the dy dx part by itself and have everything else look like some function of x times some function of y. So if I get that dy dx by itself, then over here, I'd have 7x squared minus 3x squared y, and I'm able to factor out the y squared, the x squared. So I'd have dy dx is equal to x squared times 7 minus 3y. Next step, I want to get my y's on one side and my x's on the other. So that dx needs to get multiplied over here, and that whole piece, 7 minus 3y, would get divided over. Then we're ready to integrate both sides. On the right-hand side, the integral of x squared, I get 1/3 x cubed plus a constant. And on the left-hand side, I know that we have a linear term in the denominator, so that's going to give us a natural log. So I'll have natural log 7 minus 3y. But because of that -3 in front of the y, I also need to divide by -3. If I multiply both sides by -3 now, so that's a little bit of space. So if I multiply both sides by -3, Then on the left-hand side, I'm going to have natural log of 7 minus 3y is equal to negative x cubed minus 3c. Now we have a choice to make here. If I go back and call that some first constant in this chain, then I don't have to write negative 3 times c, because negative 3 times a constant is still a constant. So I can kind of squish that together into a new single constant that I'll go ahead and call C2. Next, I'm going to get rid of that natural log and say 7 minus 3y, absolute value, is equal to e to the negative x cubed plus c2. Or we can again work our magic that this is equivalent to e to the negative x cubed times e to the c2. And e raised to a number is still a number. So I would call that a new C3. So I'd have 7 minus 3y is equal to C3 e to the negative x cubed. Now, you'll notice that I got rid of my absolute value. Let's put it back for a second. I know that with that absolute value, that's telling me that either the 7 minus 3y is equal to the positive of this, or 7 minus 3y is equal to the negative of this. Since we haven't solved for this constant yet, we'll absorb that plus or minus into our constant, so that we can get rid of both of those absolute values and know that the plus or minus is absorbed into our C3. I can move my 3y over here, subtract this over, so I'd have 7 minus C3 e to the negative x cubed is equal to 3y. And finally, divided by 3, y would be equal to 7/3. And if I divide by 3, a constant divided by 3 is still a constant. So I could call that 7/3 plus our final constant times e to the negative x cubed. Notice we got to exactly the same answer that we did when we treated it as first order linear.